We're going to talk about inverse functions. Inverse relation is our first definition. So this is going to be a relation that occurs when the order of elements is switched. So a relation that occurs when the order of elements is switched. So basically, what we're looking at is when we have x's and y's, we're going to switch x and y. So anytime you hear that word inverse, I want you to automatically think switch x and y. So if we're given this relation right here, the domain, remember, is all possible x values. So our domain would be 0, 1, 5, and 6. Whereas our range would be -3, -4, 2. Alright, the inverse is going to be when we switch our x's and our y's. So I'm just going to take the ordered pairs. Instead of 0, -3, I'm going to have -3, 0. -4, 1. 2, 5, and -4, 6. So this is the inverse of that relation. Now let's talk about the domain and range of this inverse. So my domain now is -3, -4, 2, and then -4 again. Remember, you don't have to repeat that. The range is 0, 1, 5, and 6. So the y values of that inverse. Notice my domain from my original relation is now the range of the inverse, and the range of the original is now the domain of the inverse, which makes sense because if we're switching x and y, then our domain becomes our range becomes our domain. Alright, now, is the inverse a function? Now remember, for it to be a function, each input relates to exactly one output, so basically we can't have repeating x values. If I look at my x values, I notice my -4's repeat, so the answer is no, because there is there's a repeating x value. So my x goes to 2 different y's. It's not a function. So the domain of a relation is the range of the inverse, and the range of the relation is the domain of the inverse of the relation. Alright, the graph of the inverse relation is a reflection over the line y equals x. And this should make sense because if we're switching x and y, we're just going to flip them over that line where y is equal to x. Alright, so let's go ahead and graph a couple of examples. So I'm going to graph the relation in blue, and then I'll graph the inverse in purple. So I've got a point at 0, 3, and 5, 2. Alright, so I'm going to graph the inverse. Remember, all we're going to do is switch x and y. So I've got a point at 3, 0, and a point at 2, 5. So 3, 0, and then 2, 5. And notice if this were a piece of paper and we folded it in half, these points would line up. So the point 0, 3 would match up with the point 3, 0 if it were folded over this line, y equals x. Okay, So now let's graph this linear function. And again, I'm going to graph the original in blue. I'll graph the inverse in purple. Alright, so we've got y equals 2x minus 3. Remember, this minus 3 is our y-intercept, our b-value, so our y-intercept's at negative 3. And then the 2 tells me my slope. It's positive, so we're going to go up 2 over 1. And from there we can draw a line. Alright, now in order to find our inverse, we're going to switch x and y, so I'm going to take that point when x is 0, y is negative 3, and then we can pick any of the other points. Let's just do the first point we picked, which was 1, negative 1. So we're using this point 0, negative 3, and this point 1, negative 1. And then we're going to graph the inverse. So we'll have a point at negative 3, 0, and a point at negative 1, 1. And we can draw our line. Okay, and this is the line that will reflect over that line, y equals x. Of course, it's not drawn perfectly to scale, but if you did this on a piece of paper, you should be able to fold it and see that it's reflected across y equals x. Alright, so let's discuss, is the inverse a function? So the very first graph we have is y equals x squared plus 1. Remember, that's our quadratic parent function. The plus 1 tells me I'm shifting my graph up 1. So if it normally starts at 0, 0, shifting up 1, and then we have a quadratic function. Oops. Alright, so we have a few different points here. We've got a point at 0, 1, 1, 2, negative 1, 2. We've got one at 2, 5, negative 2, 5. So for our inverse, we're going to flip our x and y. And then we're going to graph that. Point 1, 0, 2, 1, 2, negative 1, 5, 2, and 5, negative 2. Okay, so here is our inverse. Now the answer is no. And there's a couple reasons why. One is that it does not pass our vertical line test. Notice if I draw a vertical line here, it crosses in 2 different places. So it doesn't pass the vertical line test, or you may have just noticed we've got 2 2's there, 2 5's, and they're corresponding to different y values. So we've got repeating x values. So it is not a function. Okay, let's go ahead and graph this next one. We have y equals the absolute value of x. Remember, absolute value is the shape of a V. Absolute value is a distance from 0. So this graph will not have any negative y values. And then we can just take some points. We've got a point at 1, 1. When we flip that, it's just going to be 1, 1. We have one at negative 1, 1, negative 2, 2, negative 3, 3. So my 1, 1 is going to stay 1, 1. But my negative 1, 1 will become 1, negative 1. 2, negative 2. And then 3, negative 3. I'm going to go ahead and graph these. That point at 1, 1. Point at 1, negative 1. 2, negative 2. 3, negative 3. And you'll see the pattern. Okay. So again, if I try to do the vertical line test, it crosses at 2 different points, so it is not a function. And then I notice as well that my x values repeat, so that 0.11 and 1, negative 1, they repeat there. So the answer is no, it's not a function.